At CERN, inside the deep geometry of the Large Hadron Collider, physicists recently found something they were not supposed to find: a statistical irregularity where their models expected obedience. In one of the most precise arenas ever built by human hands, a measurement blinked out of alignment just enough to matter, just enough to be unsettling, just enough to remind everyone that nature still knows how to speak in the language of interruption. It was not a discovery in the triumphant sense. It was something stranger, a deviation, a hesitation, a crack so thin you might miss it if you looked too quickly. But in modern physics, thin cracks can become canyons. And if you want to keep following those cracks into the dark places where certainty begins to fail, subscribe to Beyond the Universe, because this is exactly where the familiar map stops working. That is the unnerving thing about the current era of physics. The great machine of explanation keeps running, but the universe no longer seems eager to reward our expectations. For decades, the field has lived on promises: new particles just beyond reach, hidden symmetries waiting to be uncovered, elegant theories waiting for confirmation, entire unseen architectures supposed to emerge when the energy became high enough, the detectors sensitive enough, the questions sharp enough. Yet the closer we look, the quieter reality becomes. The signals do not arrive in the numbers predicted. The hoped-for discoveries do not materialize on schedule. The noise grows complicated, but the message stays absent. And absence, when it repeats too often, begins to feel less like failure and more like intention. The anomaly at CERN matters not because it is, by itself, a final verdict on the structure of reality. It matters because it arrives in an atmosphere already charged with disappointment. This is not the first time a measurement has wobbled at the edge of the known. It is one more instance in a long sequence of strange moments in which the universe appears to lean close enough for us to hear something, then withdraws before the meaning can fully settle. A few years ago, physicists were captivated by measurements that seemed to challenge the standard model's serene confidence. Then came revisions, uncertainties, caution, recalibration. Yet the emotional residue remained. The feeling that something is not quite right. The feeling that the surface of physics is smooth only because we have not yet touched the hidden texture beneath. The standard model is one of humanity's most successful intellectual constructions. It predicts the behavior of known particles with such precision that it can describe phenomena with almost surreal accuracy. For a scientific theory, it has been an astonishing triumph, and yet triumph can become its own kind of silence. Because what the standard model does not do is just as important as what it does. It does not explain gravity in a fundamental way. It does not account for dark matter. It does not tell us why there is more matter than antimatter. It does not reveal why the universe's constants take the values they do. It is not a complete picture. It is a magnificent border wall built around a territory whose interior may still be unknown. The unsettling question is no longer whether the wall has gaps. It is whether the wall itself has taught us to mistake the border for the whole world. And that is where the recent anomaly turns from data into atmosphere, because physics has spent so long expecting the next layer to look like an object, a particle, a force carrier, a sign, a new family of interactions, that we have begun to assume discovery must arrive as something we can name. But what if the next layer does not behave like that at all? What if reality is not waiting for us in the form of a missing thing, but in the form of a missing category? What if we have mistaken silence for emptiness only because we do not yet understand the grammar of what remains unsaid? In laboratories, the word anomaly sounds almost polite. It suggests a minor irregularity, a statistical inconvenience, a line out of place. But anomalies are how the universe first appears to us when our conceptual machinery is insufficient. A strange orbit, a troublesome decay rate, a value too large, too small, too persistent, too absent. Before a revolution is recognized as a revolution, it often looks like a nuisance. That is why physicists listen so carefully to these anomalies. Not because every one of them is true, but because some of them may be the first weak knock from a room behind the wall. There is a peculiar loneliness in the current state of particle physics. The field built a cosmology of expectation. It anticipated a landscape teeming with new entities just beyond the known horizon. Supersymmetry, extra dimensions, dark sector messengers, composite structures, hidden forces, portal particles, exotic resonances. Entire conceptual species once seemed poised to emerge if only the accelerators grew powerful enough. But year after year, the promised menagerie fails to arrive. The LHC became more capable. The experiments became more refined. The theories became more beautiful, or more desperate, depending on who you ask. And still, the universe stayed mostly quiet, not mute, not empty, quiet in a way that feels almost deliberate. You can feel the pressure of that quiet in the emotional life of the field. There was a time when theoretical physics carried itself with a sense of nearing revelation. The standard story was simple. We were incomplete, but progress had a shape. Each generation would sharpen the picture. Each new machine would expose what the previous one concealed. Each inconsistency would lead, eventually, to a cleaner synthesis. But now the synthesis has not arrived. Worse, the gaps have begun to look philosophical, not just technical, not just mathematical, philosophical. Because when every practical route fails to reveal the expected next layer, the failure stops behaving like a delay and starts behaving like a message. Dark matter makes this feeling impossible to ignore. We know something is there because the universe behaves as if something is there. Galaxies rotate as though they are embedded in invisible scaffolding. Clusters of galaxies bend light in ways ordinary matter cannot explain. The cosmic web itself seems threaded through with a substance we cannot directly see, touch, or isolate. Dark matter is not a speculative luxury. It is an empirical necessity. Without it, the observed universe breaks apart at the equations. And yet, after decades of searching, the thing remains invisible in the most literal way possible. The detectors listen. The underground chambers wait. The search results accumulate. And the silence remains. That silence is difficult to think about honestly, because it carries two opposite meanings at once. On one hand, it may simply mean we have not built the right detector, not reached the right energy, not guessed the right interaction, not chosen the right window into the hidden sector. On the other hand, it may mean we are looking for the wrong kind of thing entirely. Perhaps dark matter is not a particle waiting to be netted. Perhaps it is not one object, but many. Perhaps it is not even matter in the way the word implies. Perhaps the universe has been telling us in the most patient possible way that its hidden architecture is not arranged like our models of hidden architecture. This is where the tension deepens, because modern physics is not suffering from a lack of rigor. It is suffering from a surplus of confidence in what counts as a discoverable thing. The equations are exquisite. The instruments are extraordinary. The collaborations are global feats of patience and precision. But all of this brilliance still moves within assumptions inherited from the success of past revolutions. We expect the world to yield to measurement in familiar forms. We expect the next truth to appear as a more fundamental object, a deeper interaction, a missing particle, a cleaner symmetry. Yet what if those expectations are themselves the cage? What if the silence is not empty space, but a boundary? The difficult part is that science does not typically fear being wrong. It fears being incomplete. Wrong theories can be replaced. Incomplete ones can survive for centuries, quietly shaping the horizon of thought while leaving the deepest questions unresolved. The standard model may not be false. That is what makes this so unsettling. It may simply be partial. In science, partial truths are often the most dangerous because they work well enough to become invisible. They generate the feeling that we are close, that the real answer is only one more step away. But what if one more step is not the right metaphor? What if the next layer of reality is not adjacent to this one, but orthogonal to it? What if the latter was never the correct shape? To understand why this matters, you have to imagine the intellectual mood of the last several decades. Physicists were not naive. They knew the standard model had loose ends. They knew the universe was withholding something, yet the prevailing intuition was that the withholding was temporary. There would be a deeper unification, a grander framework, a more complete language in which all the fragments would finally fit. This expectation was not irrational. It was earned by history. Electricity, magnetism, the weak force, the strong force. Again and again, what looked separate became part of a larger order. So the field learned to trust the pattern. It learned to believe the next synthesis would be even more elegant. But elegance, like every human criterion, may reflect our taste more than reality's design. And now the pattern has begun to stutter. The missing discoveries have become as informative as the discoveries themselves. The absence of supersymmetric partners at accessible energies. The failure of many dark matter candidates to leave a trace. The lack of persuasive evidence for extra dimensions, compositeness, or other obvious extensions of the standard model. The repeated narrowing of possibility without the compensating arrival of certainty. One by one, the doors that were supposed to open remain closed. And behind each closed door there is not a void, but another silence. It is the kind of silence that makes a corridor feel longer than it should be. Think about that corridor for a moment. Imagine walking through a scientific architecture where each room was expected to reveal a new principle, and instead, Every room is furnished only with refined versions of the same old furniture. New measurements, better tolerances, sharper constraints, but no hidden chamber, no dramatic breakthrough, no final mechanism, just a widening awareness that the building may not have been designed to be entered the way we assumed. You begin to wonder whether the keys are wrong, or the locks, or the idea of doors altogether. This is not how failure feels in ordinary life. This is how a map behaves when the land refuses to match the cartographer's habits. The recent anomaly at CERN therefore becomes more than a numerical oddity. It becomes a symbol of the entire predicament. In one sense, it is the tiniest event imaginable, a small mismatch among particles, a statistical disturbance embedded in the hardest-won precision. In another sense, it is a tremor in the foundations of a worldview, because if this or other anomalies survive scrutiny, they do not merely suggest a missing ingredient, they suggest the possibility that our current theoretical framework is not merely incomplete, but dimensionally insufficient, that there may be aspects of reality not expressible as additions to the current model, but only as a transformation of the model's deepest assumptions, and that possibility should unsettle us more than a dramatic new particle ever could. A new particle would have been comforting in a strange way. It would have said the universe is still speaking in the dialect we expected. It would have said, there is another piece on the board, another item in the catalog, another treasure concealed by scale. But what if there is no treasure in that sense? What if the next answer is not hidden deep enough but hidden differently? What if reality is not a warehouse of objects waiting for better tools, but an arrangement of relations, constraints, and emergent appearances that our minds persist in mistaking for furniture? At first, that sounds abstract. Then it starts to feel intimate, because all scientific knowledge is built on the confidence that reality can be translated into form. Equations, particles, fields, interactions, probabilities. We believe that if we reduce the problem carefully enough, the underlying layer will appear. But reduction may be a useful method without being a universal truth. The deeper we go, the more we may be encountering not a base layer of objects, but a shift in how description itself works. In that case, the silence in physics would not mean nothing found yet. It would mean the expected kind of thing may not exist. This is where the story begins to tilt, because once you entertain that possibility, the question changes. No longer, what particle are we missing? Instead, what if the notion of a missing particle is already too small? No longer, what is the hidden matter? Instead, what kind of reality gives rise to a world where hidden matter is inferred but never seen? No longer, why hasn't the next theory arrived? Instead, are we asking the universe to become clearer in a way it was never built to permit? These are not the kinds of questions that end debates. They are the kinds of questions that quietly dismantle the room. And still, the measurements continue. The machines keep taking data. The analyses get sharper. The exclusions tighten. The theories are pruned and amended. Everyone keeps working because science is not a theater of despair. It is a discipline of stubborn hope. But hope has an edge when it persists too long against silence. It becomes almost liturgical. The same effort repeated in the face of the same absence. The same search through the same darkness, the same conviction that the next run, the next detector, the next upgrade might finally illuminate the hidden shape. Yet perhaps the darkness is not waiting to be illuminated. Perhaps it is defining the terms of what illumination can mean. At this point, the mystery has already expanded beyond CERN, beyond dark matter, beyond the standard model. The immediate anomaly is only the first shiver in a much larger unease. If the universe keeps refusing the predicted forms of novelty, then the real issue is not just that our theories are unfinished. It is that our theories may be built around a mistaken picture of discovery itself. We expect reality to reveal itself as a more elaborate machine. But what if the next layer is not a machine at all? What if it is a rule set, a projection, a boundary condition, or something so unlike our categories that every search for it feels like trying to hear the color of a shadow? That is when the quiet becomes almost unbearable, because silence is never just silence in a field like this. It is an event. It is a measurement with no obvious source. It is a door that does not open, and thereby tells you something about the hallway. It is the universe declining to answer in the language you offered it, and in that refusal there is a kind of intelligence, or at least a kind of structure, that we have not yet learned how to name. So the question grows teeth. If the next discovery is not a particle, not a force, not a simple extension of the old map, then what exactly has modern physics been moving toward all this time? A deeper truth, yes, but maybe not a deeper object. A more complete picture, yes, but maybe not a picture made of parts. What if the silence is not the evidence of emptiness, but the edge of a more fundamental arrangement that does not announce itself through the mechanisms we built to hear it. What if the universe is not hiding in the dark? What if it is hiding in plain sight, disguised as the failure of our expectations? If that sounds like philosophy rather than physics, perhaps that is because the boundary between the two has become impossible to keep clean. The experimental results are real, the anomalies are real, the absence is real, but the interpretation of that absence, whether it is delay, error, incompleteness, or revelation, is no longer a purely technical matter. It has become a question about the limits of human knowledge itself. And once a scientific problem turns into a question about the limits of thought, the ground beneath the laboratory begins to feel less solid. The strange thing is that no single result has to be definitive for the situation to be profound. That is part of the unease. A final breakthrough would be easy to frame. A confirmed new particle would fit neatly into the history books, but we are living through something more ambiguous, a prolonged period in which nature repeatedly declines to hand over the kind of answer that would satisfy the old expectations. The old expectations were not wrong to exist. They were natural, even necessary, but they may have been too human. And perhaps that is the deepest reason modern physics now feels haunted, not by monsters but by structure, not by chaos, but by a reality whose order may be unfamiliar enough to feel like a void. What comes next is not the story of one anomaly. It is the story of what happens when several generations of brilliant minds begin to feel the same subtle discomfort, that the universe is not becoming less mysterious because we know more, but more mysterious because we have learned enough to recognize how little our concepts can hold. The silence is no longer a gap waiting to be filled. It is becoming the subject itself. And once that happens, the entire enterprise of physics shifts. The search is no longer just for particles or forces or symmetries. It is for the shape of the hidden order that makes such things possible, or for proof that our idea of hidden order has been wrong from the start. So stay with this feeling. Do not rush past it. The unease matters because it may be telling us something no confident theory can yet articulate, that the universe does not owe us a familiar answer. The anomaly at CERN is only a doorway. Dark matter is only the shadow of a deeper absence. The missing predictions are only the first signs that the map may be failing in the same place, over and over for reasons we have not yet understood. And if that is true, then we may be standing at a far more disturbing threshold than any single discovery could suggest. Because the real question is no longer whether we will find the next layer of reality. The question is whether reality was ever stacked in layers the way we imagined. And if it was not, if the silence is not a delay but a clue, then modern physics is not approaching a simple extension of the known. It is approaching the edge of a conceptual cliff, where the ground falls away not into nothingness, but into something stranger than the language we use to describe it. And once you notice that cliff, every confident sentence about the universe starts to sound provisional. Every elegant equation begins to feel like a lantern held up against a deeper dark. Every new anomaly becomes more than a correction. It becomes a reminder that reality may be less like a solved puzzle and more like an unfinished encounter, one in which the universe has not stopped speaking, only stopped speaking in the forms we expected. That is where we begin, not with an answer but with a disturbance, not with a theory but with a silence inside theory, not with proof that the universe is broken, but with the possibility that our understanding of what counts as reality may be too small to hold what is already there. And once that possibility enters the room, it does not leave easily. It waits in the background of every experiment. It stands behind every missing particle. It gathers in the spaces between measurement and meaning. It asks, without words, whether we have been searching for the next layer of the universe, or merely bumping against the limits of our own imagination. Turn back the clock to a world on the cusp of a revolution, the mid-20th century, when physics was new enough to surprise and old enough to know it had to surprise. At that time, the standard model did not yet exist. It was a vision in the making, a patchwork of ideas forged from confusion and clarity, experiment and theory, hope and skepticism. Through the haze emerged predictions that felt like promises, particles and interactions, a universe woven from a finite set of threads. The model seemed poised to explain everything we could see and perhaps much more. For a moment, it was a fortress of certainty rising above uncharted territory. And yet, from the beginning, there were signs that even this fortress might be built on shifting ground. Some expected bricks never settled into place. Some equations resisted integration. The universe whispered contradictions at the edge of calculations, troubled symmetries that refused to tidy themselves neatly. Dark matter was already a puzzle in the making, lurking as a ghostly presence in the cosmic dance, defying inclusion. You feel this long-standing tension, the powerful urge to complete what was begun, haunted by the fragments that refuse assimilation. Over decades, this tension did not dissipate. Instead, it grew taut, like a wire pulled tighter with each failed discovery. The Large Hadron Collider was built not simply to smash particles, but to shatter illusion, to glimpse what lay beyond the prevailing order. Yet despite its unmatched energies and exquisite instruments, the collider's roaring torrent of collisions revealed no new family of particles beyond the Higgs boson. Supersymmetry, the elegant mathematical symmetry that would have doubled the zoo of particles, remained invisible. Extra dimensions, predicted in some theories to elegantly balance gravity and quantum mechanics, remained undetected. What should have been a smashing confirmation of the next layer was instead an increasingly silent landscape. That silence is more than statistical scarcity. It is a conceptual heartbeat. The deeper you look, the more you start to wonder whether the very categories used to predict these phenomena are themselves the issue. Is it possible that the models refined through eras of success have begun to generate shadows of a reality they no longer capture? Could it be that particle physics, so focused on cleanliness and categorization, has become trapped in a conceptual structure that nature outgrew long ago? Dark matter sharpens this philosophical razor. It demands an explanation powerful enough to shape the cosmos, yet it evades every attempt to pin it down at the scale of particles or fields. Experiments deep underground, submerged in ultra-pure substances designed to catch even the faintest finger of an interaction, return nothing but silence. Astronomical observations compound the paradox. Galaxies and clusters dance to a rhythm dictated by something invisible, but that something remains stubbornly out of reach. And so the question that once seemed exclusively physical starts to feel ontological. What kind of existence is this dark matter? What kind of something resists all instruments designed precisely to find it? The Standard Model's silence around dark matter is not failure. It is a kind of eloquent refusal. It speaks not by presence, but by absence. And once you allow this silence to speak, it unsettles the foundation of what science means in this domain. Because science moves forward by capturing phenomena in measurable, relatable terms, definable variables and verifiable entities. But what if some components of reality evade being framed as things? What if being in the universe includes modes of existence that do not conform to our notions of particles, waves, or forces? The implications ripple outward. Is science, as practiced, equipped to recognize such modes? Or have we built our instruments and concepts precisely to miss them? Consider this slowly. The universe, in its vast complexity, may not be an intricate clock with hidden cogs waiting to be discovered. Instead, it may be more like an echo chamber, a place where observations reflect not just the universe, but the observer's history of expectations and conceptual structures. In that echo, the failure to find a predicted particle is not just a missing note. It is feedback that the score itself may be written wrong. You start to realize that the silence at CERN and similar experiments could be the universe's way of signaling, stop searching here. But where then should your gaze turn? The crisis is not only empirical, it touches the very architecture of scientific knowledge. The dominant language of theoretical physics, symmetry, locality, reductionism, has served with brilliant success. Yet what if these principles, pillars of the past century's breakthroughs, are just approximations? What if the universe obeys them only in limited domains, not as absolute rules? In recent years, hints of this possibility have multiplied. Non-local phenomena in quantum mechanics confound the neat separability once assumed to be fundamental. Emergent behavior, where complex systems generate unexpected properties, questions the assumption that the whole can be understood entirely through its parts. Could the universe's deeper layers be shaped by new principles we have yet to conceptualize? The philosophical stain grows darker when considering the nature of measurement itself. Quantum theory taught us that observing a system changes it, that reality at fundamental scales is not fixed but probabilistic, relational. Yet our contemporary experiments are still predicated on classical intuitions embedded in this fragile framework. Perhaps there lurks a dimension of reality where concepts like particle, field, and even observer dissolve, replaced by relational webs or pre-geometric structures. If so, the forever elusive signals are not missing because we lack sensitivity. They are missing because our questions have the wrong grammar. In that sense, the growing silence in physics is not a void, but a mirror. It reflects not only what you have not found, but how your methods, your concepts, your expectations have shaped what counts as a findable thing. It requires a shift from the perspective of looking for new pieces to examining the shape and limits of the frame itself. The anomaly at CERN cracks open this mirror, inviting the observer not just to see deeper but to see differently. And yet, despite the increasing weight of this crisis, the pursuit continues with unwavering faith. Physics has never been a discipline to yield quickly to silence or mystery. The hope is that, like all prior revolutions, the current stall will end with the emergence of a clear, decisive breakthrough. But the longer the wait, the harder it becomes to ignore the possibility that the impediment is not technological, but conceptual. That the universe's message to us is not only look harder, but also look differently. This possibility unsettles because it asks you to consider failure, not as an endpoint but as an invitation. What if modern physics has reached a horizon where progress demands a radical transformation of its foundations? What if particle accelerators, detectors, and equations, no matter how refined, cannot by themselves take us past this conceptual boundary? To break through, would you have to invent a new language of reality? Would you have to abandon familiar comforts, particles as basic, symmetries as sacred, constants as immutable, and embrace forms of existence that defy intuition? If such a revolution is underway, you are witnessing more than a branch of science recalibrating its model. You are witnessing the beginning of a profound philosophical rupture, one that challenges the assumption that reality can always be unfolded like a map in finer detail. Instead, it suggests reality might be an evolving architecture, whose blueprints are not fully accessible through reduction, but that demand new principles of emergence, relation, and possibly something we have no word for yet. The metaphor that returns again and again as you navigate this landscape is not a machine, not a clockwork, but an abyss. Not an abyss of emptiness, but an abyss of ungrasped complexity, a realm where familiar categories fragment and dissolve, where silence reverberates with possibilities that feel more like questions than answers. This abyss is not a place you can simply look into and understand. It is a presence that shapes even the act of looking. It waits in the gaps between theory and experiment, between expectation and observation, between what is said and what remains unsaid. And that abyss feeds a new kind of dread, a lucid dread born not of superstition, but of intellectual humility. You sense that what lies beyond is not chaos, but something stranger still, an order that does not conform, a pattern that is not fully representable, a reality emerging beneath and beyond the reach of your best tools and sharpest concepts. The great quiet at the heart of physics is then not failure or defeat. It is a whisper of an entirely new horizon, one you can neither summon nor quite deny. Slow down here. Feel the weight of the emerging realization. The silence you've been following is not the absence of something waiting to be found. It may be evidence that the questions you thought mattered are themselves incomplete. The Standard Model and its extensions, these titanic achievements, may be the surface crystallization of deeper dynamics that refuse reduction. The anomaly at CERN, the quiet of dark matter hunts, the failure of countless elegant theories. What if these are not signposts pointing toward another particle hiding somewhere in the cosmic shadows? What if they are all reflections of a fundamentally different kind of hiding, one that challenges the very idea of finding as we know it? What if reality itself is not structured like a layered palace, with secrets hidden behind doors at every level, but more like a hall of shifting mirrors? The reflections you chase are always partial, distorted, contingent on perspective and method. Every experimental breakthrough, every mathematical triumph, every theoretical edifice is a reflection in this hall, a fragment shaped by the interplay between observer, instrument, and the inscrutable structure they probe together. The anomaly becomes not a crack in the facade of reality, but a fracture in the glass through which you gaze, a hint that the reflection is less a revelation and more an echo. Imagine what this means. Your search for new particles as fundamental building blocks could be as misplaced as trying to find the edges of a fractal. The architecture of reality may not be an assembly of parts, but a dance of patterns, a hidden order that does not decompose into smaller pieces but emerges instead from the relations between them. The silence of dark matter is not a failure of detection, but a message about the very language of existence, that some components of the cosmos resist being cataloged as things at all. This possibility reaches beyond physics and strikes at the heart of human knowledge. It suggests that the familiar instruments of science, measurement, classification, prediction, may operate perfectly within domains, but become inadequate when pressed too far into the unknown. We are not merely technologically limited, we are conceptually constrained. The boundary is not simply the horizon of what we can measure, but the horizon of what we can conceptualize, where our cognitive frameworks, our metaphors, our very modes of understanding reach their limit. In this reframing, the anomaly at CERN appears less as a gateway and more as a symptom of the growing misalignment between what the universe offers and how we are prepared to receive it. The silence is not a failure to discover new particles, it is a silence imposed by conceptual boundaries. The Standard Model's quiet spaces are no longer gaps to fill but shadows cast by the limits of human inquiry. The missing pieces are not missing objects, but missing languages. This idea is more than unsettling. It is transformative. It evokes a philosophical rupture, reminiscent of the moment Copernicus realized Earth was not the cosmos's center. But here, the rupture is subtler and more disquieting. Instead of stripping humanity of place in the universe, it strips the universe of the familiar shape of reality itself. It suggests that the familiar categories, space, time, particle, field, force, may be emergent approximations rather than fundamental constituents. Once you accept this, your intellectual ground shifts beneath your feet. It forces you to confront questions that hover at the edge of science and philosophy. What does it mean for something to exist if it refuses detection? What does it mean for a theory to be true if it cannot fully represent reality? Can knowledge be complete in a universe where reality itself escapes the frameworks designed to capture it? You begin to see knowledge not as a linear accumulation of facts, but as a mosaic of perspectives, each incomplete, each shadowed by the limits of expression. In the shadow of this reframing, scientific progress does not falter, but transforms into a kind of profound humility, a slow surrender to the unknown, not as a failure, but as an essential dimension of existence. The failure to find the next particle is no longer a defeat, but a signal that you may have been lifted too quickly from partial victory to final certainty before the story was truly ready to be told. It invites you to linger longer in the corridors of mystery, to value questions more than answers, and to recognize that some silence is itself a message worth deciphering. Perhaps then, the universe's greatest secret is not hidden in the accumulation of smaller parts, but in the architecture of absence itself. The silence between discoveries, the intervals where expectation pauses and the familiar patterns dissolve. This architecture might be where new physics awaits, not as additions to an equation, but as a new language to read the cosmos. A language where absence, silence, and gaps are not just obstacles, but syntax and meaning. You have now arrived at the threshold of a concept both unsettling and expansive, that the end of physics as you understood it may be no end at all. Instead, it may be the opening of a new domain that questions the very texture of reality, in which your tools must become less the instruments of capture and more the instruments of interpretation. The universe you know would remain, but the foundation beneath your understanding would shift. Less an unchanging ground and more an evolving horizon. This horizon is not a destination, and it offers no comforts. It waits silently for you to look, not with the eyes of certainty or completion, but with openness and wonder shadowed by doubt. It invites you to embrace the possibility that reality is stranger than any theory proposes, more elusive than any experiment can contain, and more profound than any prediction can reach. It is a realm where every anomaly is a crack in the glass of understanding, the abyss mirrored perfectly and infinitely in your quest. So as you reflect on the recent anomalies, on the endless silence of dark matter, and on the collapse of grand predictions, understand that the story is not simply about failing to find what was expected. It is about challenging the very nature of expectation itself. It is about recognizing the limits of the map and opening yourself to the vastness of the unknown territory beyond, where the next move is not a discovery, but a reimagining. And that is the true legacy of the growing quiet inside modern physics. It does not confirm the end of wonder, but announces the beginning of a deeper, stranger, and more mysterious questioning. A questioning not of what reality is made of, but of what reality could mean. Beyond the universe, this is where the journey continues, not toward final answers, but into the expanding silence where silence itself becomes the most profound clue. Now lift your gaze beyond the particle collisions and the machinery of laboratories. Extend your vision outward, beyond the Earth, beyond the solar system, beyond even our own galaxy. There, the universe stretches vast and dark, a stage inhabited by mysteries that dwarf any particle or anomaly observed in subterranean detectors. It is the realm where cosmology and fundamental physics meet, where the silence inside the Standard Model amplifies into a cosmic quiet so profound it trembles at the edges of understanding. Consider the cosmic web, an immense tapestry of galaxies and galaxy clusters linked by filaments stretching billions of light years. This grand structure moves and evolves as if shaped by an unseen hand. The gravity that scaffolds the universe disagrees with the visible matter it should trace. It draws galaxies into orbits that defy the mass we can account for, demanding the presence of something else. This something, dark matter, remains ghostly, unyielding to attempts at direct detection. You know the evidence is overwhelming, but the actor itself refuses the stage. What does it mean that the universe's grandest architecture depends on an unseen substrate? Theories proliferate, particles, fields, modifications to gravity itself, all propose to fill the void. Yet none have definitively crossed the threshold from hypothesis to known entity. This silence weaves into the fabric of cosmic evolution itself, as if the universe is structured not just by matter but by something fundamentally different that our instruments, built for probing particular scales and interactions, cannot grasp. At the largest scales, the universe's expansion accelerates mysteriously, propelled by an elusive, dark energy. Where dark matter anchors structures, dark energy scatters them, pushing galaxies apart with invisible force. This dual absence, dark matter and dark energy, marks the limits of the standard model and the general theory of relativity, the twin pillars of modern physics. Together, they expose fissures in the grand narrative of matter and forces. Together, they hint at a deeper, unseen architecture. You begin to feel the scope of the subtle pressure exerted by these absences. The physical universe insists on being more than the sum of observed particles and forces. These cosmic silences expand the anomaly from a measurement in a collider to a universal condition. The universe itself may be structured by hidden principles that transcend locality, particle identity, or even time and space as conventionally understood. The growing quiet is cosmic. It is ontology writ large, and yet, as cosmic as these questions are, they remain intimate. They penetrate to the core of how human beings understand themselves in relation to the cosmos. We exist within the universe, yet it is opaque to complete comprehension. We map the heavens with ever more sensitive instruments, yet the universe responds with silent contradictions. This is not failure but a continuing conversation, where we hear echoes of an answer waiting beyond the reach of habitual thought and measurement. The philosophical implications of this silence resonate through the corridors of inquiry. How do you probe a reality that refrains from revealing itself through expected channels? How do you build knowledge when the framework of knowledge itself may be provisional? Is the universe's hidden architecture something you can ever fully model, or must you accept that some aspects remain forever beyond formalization, accessible only through metaphor, intuition, or new ways of thinking not yet cultivated? This is the moment when physics bleeds into philosophy, a moment where the clarity of empirical approach begins to merge with the ambiguity of foundational questions. The anomalies, the absences, the silences are not just technical hurdles. They are signposts pointing toward conceptual frontiers. Science is calling forth a more nuanced epistemology, a way of knowing that embraces incompleteness, ambiguity, and the subtle textures of silence. Imagine standing on the shore of a vast ocean at dusk, the surface smooth and infinite. The ocean is the unknown underlying reality, and your physics is a rowboat you've crafted to cross it. For decades, the boat has carried you far from land, revealing new wonders. But now the waters lie eerily still, the horizon unbroken. The storm of discovery has lulled. Is this calm a pause before the storm, or the sign that you have reached a sea that cannot be crossed by your current vessel? What awaits beyond? A new continent to chart, or a vast abyss that defies mapping? It is in this metaphorical ocean that the growing silence finds a form. It is the abyssal depth beneath the waves, vast and unexplored, where new rules may govern the shape of reality itself. It compels you to ask, is reality fundamentally a vast network of relations, a dynamic of emergence, a projection of unknown structures? Or is it more radical, a realm that defies division into objects, causes, or even history? In confronting this abyss, you are forced to confront your own anticipations and assumptions about what it means to know. Scientific knowledge, so powerful within domains of certainty, here meets its horizon. The search for new particles, new fields, new forces may be akin to throwing stones into the ocean, hoping for ripples to reveal hidden land. But what if the ocean's depths are shaped precisely so that the ripples cannot travel where you expect? What if reality has a logic not reducible to the sum of its observed parts? That is the most profound tension modern physics contends with, a tension not between theory and experiment alone, but between the known and the unknowable, the describable and the ineffable. The recent anomaly at CERN is the smallest trace of this immense structure, the silence of dark matter and dark energy, its cosmic shadow. Together, they form a constellation of absence, a map not of what is, but of what cannot be expressed in the language inherited from past revolutions. This map urges caution and humility. It reminds you that science does not merely progress by disclosure of secrets, but sometimes by recognition of limits. Limits not imposed by the failings of humanity or instruments, but those that arise naturally at the interface between human cognition and the deep architecture of the cosmos. And in that recognition begins perhaps a new era, not one characterized by confident assertions of final theory, but by a patient exploration of silence itself. An exploration where absence is not a blank to be filled, but a medium to be understood, where silence is not failure, but message. And now the question begins to change shape, not because the evidence disappears, but because the evidence starts to point in a direction no one expected. The anomaly at CERN fades from being the centerpiece and becomes instead a symptom of something wider, older, and more difficult to name. The missing particles, the invisible matter, the repeated failure of elegant extensions to survive contact with reality. These are no longer isolated frustrations. They begin to resemble a pattern, and patterns once noticed are rarely innocent. For years, the story was supposed to be simple. The standard model was incomplete, so new physics would arrive as an expansion of the menu. A new field here, a new symmetry there, a heavier partner to this particle, a hidden mediator for that force. The universe would remain recognizable, only more crowded. But each passing decade has made that assumption harder to defend. The additions keep failing to appear in the forms predicted. The silence remains stubbornly intact, and the silence is now beginning to look less like a temporary condition and more like a property of the terrain. This is where the conceptual twist takes hold. What if we have not been walking toward the next layer of reality at all? What if we have been circling the edge of a deeper condition that does not present itself as a layer, but as a rule for how layers become visible in the first place? That would mean physics is not merely missing a few ingredients. It may be misunderstanding the kind of thing it is trying to find, not a hidden object, a hidden framework, not another particle, another mode of reality's self-organization. That thought changes the emotional temperature of the entire story. Because if reality is not built the way our theories assume, then the failure of those theories is not simply a setback, it is a warning. The universe may be answering correctly to questions we have not yet learned to ask, and in that possibility lies something more disturbing than error, the possibility that our methods are exquisitely successful inside a limited domain while becoming blind just beyond it. Not broken, not useless, limited in a way that is difficult to detect from within. You can feel the philosophical floor begin to shift here. Every scientific system rests on unspoken assumptions about what counts as an object, a cause, a law, a boundary, a measurement, a prediction. We rarely notice those assumptions because they work. They have worked so well that we began to treat them as inevitabilities. But the disappearance of expected discoveries is forcing those assumptions into view. Why should the universe be obliged to reveal itself as a collection of discrete, isolatable parts? Why should hidden reality behave like a better version of visible reality? Why should the deepest order resemble our instincts about order? The more you think about it, the stranger the silence becomes. Not empty, not passive, structured, a silence with contour, a silence that persists across experiments, scales, theories, and eras. A silence that may be telling us that the thing we seek is not absent, but incompatible with the current shape of our questions. And once that idea enters the mind, it is difficult to remove, because it implies that reality may not be a puzzle waiting for completion, but a system that only appears solvable if you misread what kind of system it is. This is where the abyss returns, but differently now. Earlier it seemed like the abyss of ignorance, the dark below the edge of current knowledge. Now it feels more like a structural abyss, a gap between the forms our minds can hold and the forms reality may actually take. The abyss is not just out there, it may run through the center of the map itself. It may be part of the architecture, and if so, then every confident assertion about finality begins to sound premature. There is a profound irony here. Physics has become more precise than ever, and yet precision has not translated into closure. The measurements are better, the constraints are tighter, the instruments are more extraordinary than any earlier generation could have imagined, and still the key revelations do not arrive. It is as though the universe has granted us a sharper lantern, only to ensure that the darkness now appears with more terrifying detail. The light has improved, the mystery has not reduced. Maybe that is because the mystery was never a lack of light. Maybe it was a mismatch between illumination and shape. Maybe the thing we are trying to see does not lie hidden in the dark but sits at an angle to all our beams. If so, then the silence is not a blank. It is a refusal by reality to conform to the assumptions of the observer. Not a refusal to be known, but a refusal to be simplified into the kinds of known things we already have words for. That possibility makes the standard model feel less like a completed theory and more like a remarkably successful local language, powerful, precise, and incomplete in a way that only becomes obvious when pushed to the edge. Its silence is not a defect in the ordinary sense. It is a boundary marker, a place where one language ends and another, as yet unspoken, may begin. And the tragedy, if it is a tragedy, is that we may be mistaking the border for the whole continent. The larger implication is almost impossible to absorb without resistance. If reality has hidden aspects that do not yield as particles, fields, or forces, then perhaps the most fundamental layer is not material in the way we imagine. Perhaps it is relational, informational, computational, topological, or something stranger still, a substrate in which what we call matter and energy are only emergent effects, surface expressions, projections of a deeper grammar. That sounds speculative, and it is. But so did every major conceptual breakthrough before its time. The difference is that now the silence itself pushes us toward speculation, because ordinary expectation has run out of fuel. At this point, the documentary is no longer really about CERN, or even about dark matter. It is about the shock of discovering that the universe may not be organized around the things we thought were most real, that the visible order may be secondary, that the most important structures may not announce themselves as objects at all. And if that is true, then every detector, every collider, every equation is not simply looking for hidden content. It is trying to translate a reality that may not be expressed in content-based terms. The emotional effect of this realization is hard to overstate. It is one thing to believe there is more to discover. It is another to suspect that discovery itself may need to be reinvented. The science remains rigorous, the experiments remain vital, but the ground beneath them begins to feel less like solid terrain and more like a threshold. The sense of standing at the edge of comprehension becomes unavoidable. You are not looking into a void. You are looking at the possibility that the void is a misunderstanding. And if that is the case, then the silence is not asking to be filled. It is asking to be interpreted, not as lack, but as structure, not as defeat, but as evidence that the universe is not obligated to wear the costume of our expectations. That is a difficult thought to sit with, because it removes the comfort of progress as simple accumulation. It suggests instead that progress may involve losing the wrong picture before gaining the right one. This is why the current moment in physics feels heavier than a typical scientific impasse. It is not merely a backlog of unsolved problems. It is a confrontation with the possibility that the very form of explanation is due for revision. The growing quiet inside modern physics may be the first audible sign of that revision, a sign that reality is not less understandable than we hoped, but more unlike our habits of understanding than we ever imagined. And so the story bends toward its most unsettling destination. The universe did not promise to be intuitive. That much was always known. But what if it also never promised to be decomposable into the kinds of units we seek? What if there is no final inventory of particles because the deepest level of existence is not a warehouse, but a process, not a set of objects, but a system of constraints and transformations that only ever partially reveal themselves? Then the silence is no longer a failure of the search. It is the sound of the search colliding with the limits of its own assumptions. That collision does not end the pursuit. It transforms it. It forces the question into a new form. Not what have we missed, but what if what we call reality has always been something stranger than a missing piece can explain? And once that question is truly asked, the universe begins to feel less like an unfinished machine and more like an unfinished encounter, one that has not yet decided what it is willing to become to our minds. If the earlier chapters of this journey felt like a descent into uncertainty, this is where uncertainty begins to look almost intentional. The question is no longer whether modern physics has found all it can find. The question is whether the universe itself permits the kind of completeness we keep trying to impose on it. And the more carefully you listen, the more that possibility stops sounding absurd and starts sounding unavoidable. This is not a story about defeat. It is a story about exposure. The silence around dark matter The silence at the edge of collider experiments. The silence where new symmetries were supposed to emerge. All of it exposes the shape of our expectations. We assumed that deeper truth would resemble clearer machinery, more parts, sharper laws, cleaner equations. But perhaps depth is not additive. Perhaps it is disruptive. Perhaps it strips away the very categories with which we hope to grasp it. That would explain why every triumph seems to end in a larger question than the one it solved. Every answer in physics has a way of opening a doorway into a darker room. And now the room is so dark that even the architecture begins to disappear. Not because there is nothing there, but because the forms we rely on to identify something may not survive intact at that depth. The mind reaches, and the universe does not break. It simply does not fit. The unsettling part is how ordinary this transformation can feel at first. A disagreement between theory and experiment, a null result, a missing particle, a detector that sees less than expected. On paper, these are just technical complications, but taken together, they behave like the early tremors of a conceptual earthquake. The ground is not vanishing, it is moving, and the movement is subtle enough that only the most attentive witnesses notice the floor has changed before the walls do. Perhaps this is why the public imagination often latches onto the language of catastrophe when science enters a phase like this. It feels like a collapse because something familiar is indeed collapsing. The confidence that reality will continue to reward the same questions with the same style of answer. But collapse is only one way to describe a transformation. Another way is liberation. The old picture falls apart not because nature is hostile, but because it has exceeded the scale of the image. So the task now is not simply to search harder, it is to become capable of receiving a different kind of answer. That may mean revising what counts as evidence. It may mean taking seriously phenomena that do not announce themselves through the familiar signatures of particles and forces. It may mean accepting that some truths will first appear as absences, correlations, asymmetries, or structures of impossibility before they ever become objects in the ordinary sense. If that sounds abstract, good. It should. We are nearing the edge of language here, where precision and metaphor begin to trade places. At this edge, physics becomes philosophy not because it becomes vague, but because it becomes foundational. It asks what kinds of things can exist, what kinds of things can be known, and whether knowing always requires the thing known to appear as a thing at all. The deepest disturbance, then, is not that dark matter remains unseen. It is that unseen reality may not be an exception to physics but a clue to its next form. The hidden may not be an anomaly at all. It may be normal at scales, conditions, or modes of existence we have not yet learned to inhabit conceptually. If so, then the universe has not failed to answer. It has answered in a language we are still trying to hear, and that possibility carries a strange kind of hope. Not comfort, hope, because it means the unknown is not exhausted, not closed, not destined to be reduced into a final list. It means there is still room for surprise that is not merely technical but civilizational, room for a shift in the human picture of reality large enough to alter what it means to investigate, to explain, to understand. We are not standing before emptiness. We are standing before a threshold whose shape we do not yet know. So the final image is not of a machine winding down, nor of a theory dying in disgrace. It is of a civilization learning, however reluctantly, that its best map may still be a partial one. The map is extraordinary. It has taken us far. It has revealed galaxies, quarks, fields, and the deep regularities of nature with astonishing power. But it may also have reached its edge. And at that edge, silence is not a mistake in the chart. It is the sign that the coast no longer matches the drawing. This is where the story leaves you, not with an answer but with an alteration. The universe remains, indifferent and magnificent. The equations remain, precise and incomplete. The detectors remain, patient and listening. But the listener has changed. Once you have truly heard the silence, you cannot return to the old confidence that reality is simply waiting to be catalogued. Something has shifted irreversibly in the relation between mind and world. And that is the final, unsettling truth at the heart of this journey. The growing quiet inside modern physics does not merely mark the absence of discovery. It marks the birth of a new kind of question, one that may not be answerable by adding more pieces, but only by learning how to think beyond the idea that reality must arrive as pieces at all. Beyond the universe, there may not be an end. There may be a widening, and in that widening the silence continues.